जाएंगे। Good morning, students. Today, with the continuous series of differential equation, yesterday we started normal reduction form of differential equation with variable coefficient. We change differential equation in a normal form when the variable coefficient. The normal form is just d2v upon dx2 plus iv is equal to s. This form is called normal form, and here we take the solution y is equal to uv. U we get from u is equal to e की power intersection pd half pdx, and then we get v from with the help of u, and the complete solution is y is equal to u. So student, this is the learning objective of our lecture, to know about the variable coefficient and normal reduction form of or vari, variable coefficient differential equation. Now we come to the our lecture. Today we are planning of two questions minimum to do in this lecture. We see how much possible. Now first question I'm taking. Let solve the differential equation. Solve the differential equation. d2y dx2 plus 1 upon plus 1 upon 4 x की power 2 by 3 minus 1 upon 6 x की power 4 by 3 minus x की power square 6 upon x square. Here differential equation is d2y dx2 plus 1 upon x की power 1 by 3 dy upon dx plus 1 upon 4 x की power 2 by 3 minus 1 upon 6 x की power 4 by 3 minus 6 upon x square. This is upon y is equal to 0. So solve differential equation now. Here c is equal to 1 by 3, q is equal to okay, and r is equal to 0. We know let u is equal to uv is the solution of differential equation. So u is equal to, we know, a की power half pdx. So a की power half P is equal to here 1 upon x to the power 1 by 2b. So P is equal to minus 3 by 4 x to the power 2 by. This is equation 1. Now now we find we have normal form of differential equation is d2b upon dx2 plus iv upon. This is our normal one. Now here we need I. So I is equal to we know q minus 1 upon 4 p square minus 1 by 2 dp. Q value of q is equal to when we put the value we get P is equal to minus 6 upon. The equation is become. Now this can be written as d3 dx minus 6v. It can be written as d minus 1 minus 6 here. This is the homogeneous form. This is homogeneous form. So x is equal to e to the power z implies z is equal to log x. Okay, here we introduce new variable z and x is equal to we take assume e to the power z and z becomes log x. So d2v upon dx to convert in the d minus 1. Now this is the value. So so this is the root of differential equation and this is the real and mystic. So we can say so we write C1 e की power 3 z plus C2 e की power minus 2z. Here put the value of z, we get C1 e की power 3 log x plus C2 e की power minus 2 log x. Here we get x2 plus C2. Now complete solution is y is equal to u. U is equal to we have okay. Now the CF is now CF is now we put the value of u and v here. U is equal to we have u is equal to value of u e की power minus 3 by 4 x की power 2 by 3 by 3 multiply with 3 2 6. This is the form of okay, and this is the our solution. This is our so student in normal form we will see that is very easiest form to solve the equation differential equation. Actually given equation in this form we write q value, p value, q value and r value. Okay. We know u is equal to half pdf half integration pdf. So e की power half e की power x by 2 is become this form. We have normal form d to v upon dx plus I is equal to f. So and q is equal to this. So we put value in this normal form equation. Here this is converted to x square d to v dx2 is the form of homogeneous system. So we put x is equal to e की power z, z is equal to log x. By the solve this we get CF this. So the complete solution is UV. So we can write this way. Now, now we take another example based on this method. D2V dx2 2 upon x dv upon dx plus y is equal to sin 2x upon x. Solution. We find that p is equal to 2 upon x, q is equal to 1, and r is equal to sin 2x upon x. Okay. Now, 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 student, p is equal to this, q is equal to this. Now take, now we take y is equal to uv is the complete solution. Complete solution. So u is equal to e की power half pdx. Half pdx. So e की power half p is equal to 2 upon x dx. These 2 to 2 cancel. It becomes e की power log x is equal to. This is our here. Here u is equal to here minus is already here. So this will become 1 upon x. Okay. This is our 1 upon x. Now normal form of differential equation d2v upon dx plus iv is equal to. This form is called the normal form. Okay. Now here qi is equal to here I is equal to q minus 1 by 4 minus half dp upon sorry p by 2 du upon q is equal to sorry I is equal to q minus 1 by 2 dp upon dx 1 by 4 p square. So here q is equal to 1 half dp upon dx is minus 2x cube for p square में 4x. Is equal to So I we get the value of I is equal to now. Now we put both I here. One more requirement is our S. Here we find S. S is equal to R upon value of U is equal to 1 upon X. So R is equal to sine 2x upon X and value of 1 upon X. So it convert in sine 2x upon X, X upon 1. So, so our normal form is now our normal form of differential equation. We put value of I and S in this equation, so become d2v upon dx2 plus I is 1 dot v s is sine 2. This is our equation. We can write like that d2v dx square plus v sine 2. Okay. Now we can write like that d square plus 1 sine 2. This is our this is higher order differential equation with with constant. Now Now, this is higher differential equation with constant coefficient. Now, the solution we know this type of equation. We make the auxiliary equation first. So d square plus 1 is equal to 0. D is equal to plus minus iota. The CF is we know that when the root of the auxiliary equation is in complex form, then we know the CF solution is y is equal to e to the power alpha x is cos beta x plus b sin beta x. But there alpha is equal to 0. So we direct put the value and beta is equal to 1. So we get a cos x plus b sin x. Equation number 3. Now for pi, now pi is equal to 1 upon d square plus 1 sin 2x sin 2x. Here we know this is the form of sin alpha x. When the form in sin alpha x, we replace d square as minus alpha x square. If f d square is not be 0. So here we put sin x minus 2 cos square plus 1 sin 2x upon 3. Okay, this is our pi. Now the complete solution for b is cf plus pi. The complete solution cs can be written as cf plus pi. cf is equal to a cos x plus b sin x minus sin 2x upon 3. This is the value of b. Now we have the solution of given equation uv. Here u is equal to, we already find the value of u is equal to 1 upon x. So put value is 1 upon x, a cos x plus b sin x minus sin 2x upon 3. This is our complete solution. This is our complete solution. Again I repeat this question. The given equation in the p is that 2 upon x, p is equal to 1 and r is equal to sin 2x upon x. We take the complete solution is y is equal to u. So u is equal to, we know u is equal to e to the power minus half p dx. E to the power minus 2x, 2 to cancel, this convert in 1 upon x. So we get the value of u is equal to 1 upon x. Now we know the normal form of differential equation d2v upon dx2 plus iv is equal to s. We have to find out the value of I. I is equal to nothing q minus 1 upon 4 p square minus 1 upon 2 dp upon dx. So when we calculate this, put the value of dp upon dx and p square, we get I is equal to 1. I is equal to now value of s is equal to r upon u. R is equal to sin 2x upon x 1 upon sin 2x. We get the value. Now this value when we put in the differential equation it convert in the constant coefficient in this d square plus 1 is sin 2x. Now d is equal to find the value of d is equal to plus minus iota. The roots are we find imaginary. So the CF solution is become a cos x will be sin x and pi is equal to 1 upon d square plus 1 sin 2x. So we put alpha d square replaced with minus alpha square. So the complete solution of this type of equation CF plus pi we find value of v. And we assume that the complete solution of normal form is y is equal to uv. So we get this is our solution. So I think students you are comfortable with this method. Now now d2y dx2 minus 2 upon x dv upon dx now in this lecture in this question p is equal to minus 2 upon q is equal to 1 plus 2 upon x and r is equal to x to the power. Here again we have to calculate first u. Let uv is the solution of let be the solution. So q is equal to e to the power minus half t dx. 2 to cancel log x will be. So we find here u is equal to x. Okay, so u is equal to now now just we find add the equation normal form of equation is d2v upon dx2 plus iv is equal to here I is equal to q minus dp upon dx. So q, what is the value of q? Q is equal to 1 plus 2x cube 1 by 4 p square. What is the value of p square? 4x square. 4 upon x square. dp upon dx is equal to 2 upon x. So here 4 to 4 cancel. So 1 plus 2 upon x square minus 1 upon x square minus 1 upon x square. Again we get this is cancelled, this is equal to 1. So I is equal to 1. So I is equal to 1. Here again we put the normal form S is equal to R upon U. R is equal to, we know value of R is x e to power x, or U is equal to x. So become so now so now the equation normal form of equation can be written as d2v upon dx2 plus 1 dot v is equal to e to power, where implies d2v dx2 plus v is equal to e to power. So d square plus 1 v e to power. Here value of d is equal to plus minus I. So here we can write again, here v is equal to a cos x plus b sin. Now pi, particular integral, pi is equal to 1 upon d square plus 1 e to power alpha x. We put d is equal to 1 alpha. Fd convert in the f alpha. Here alpha is equal to 1. So we put d is equal to 1, then we get ex 1 square plus 1 is equal to akx upon. Now complete solution, a cos x plus b sin x plus e to power x by. This is our complete solution. We can say v, value of v. Now we know that u is equal to is the complete solution. So so put value of u and v. U is equal to x and v is equal to a cos x plus b sin x. here u is equal so y is equal to the complete solution x b sin x equals a x cos x b x sin x plus x e k x y. This is the complete solution. So I hope student this method is clear to you in this video. Now we are coming to the quiz. Now student, let's go to the quiz very quick. Condition when the solution y is equal to x to the power m. I already told you this is the form of when one CF solution is given to you, then this can be defined by m minus 1 plus 2 pm plus mf square. Then we get y barabar x to the power m. And 1 is there, substituting p plus qx is equal to 0 when we get y is equal to m. dy upon dx is the same question. In normal reduction form, u is equal to e to the power minus half integration p dx. If expansion e to the power mx, this is already from question I have already taken in the form of when solution is known, then 1 plus p plus q is equal to 0 e to the power x is the solution we take. S is equal to R upon U. The value of S is equal to R upon U. So, sister, thank you very much. Thank you very much. And this method is very, I think, very easy and easily you can attempt in the examination. So, be focusing on this method and continue. We will do the another method an independent variable chain. So, thank you very much.